Today I will be covering writing a chemical formula in this short video clip here. To begin with, ionic compounds are composed of metals and nonmetals, an example being sodium chloride, NaCl. The metals are called cations and have a positive charge. An example is sodium, +1, or Mg, +2. The nonmetals are called anions and have a negative charge, an example being chlorine -1, nitrogen -3, or oxygen -2. The octet rule dictates that metals give up valence electrons to get to 0. Sodium will give up 1 valence electron to get a +1 charge. The octet rule dictates that nonmetals gain valence electrons to get to 8 valence electrons. Chlorine will gain 1 valence electron to get to a -1 charge. Why does an element gain a charge and become an ion? Sodium has 11 protons and 11 electrons. Protons have a positive charge and electrons have a negative charge. So these normally balance out. 11 minus 11 gives you a difference of 0. Now when sodium gives up 1 valence electron, it now has 11 protons and 10 electrons, which gives it a +1 for protons and a +1 charge. To write an electron dot configuration, the first step is to determine what the symbols are for the elements. Then, this can be found by going to the periodic table. Then you're to determine the number of valence electrons, which can be found by looking at the group in which those elements are located. Depending on the number of valence electrons, you're going to put that amount of dots around the symbol. You will have a maximum of 8 valence electrons. After determining this, you're going to move valence electrons to get metals to 0 valence electrons and nonmetals to 8 valence electrons. If you need to add additional atoms, add additional atoms until all metals and nonmetals are to 8 or 0. After having all the valence electrons moved so that metals have 0 valence electrons and nonmetals have 8 valence electrons, you can then count up the number of metal atoms that were necessary to do so, and you will write down the symbol and using the subscript how many metal atoms were necessary. Then you will count up the number of nonmetal atoms that were necessary, and you will write down the symbol for that nonmetal and write the subscript for however many atoms were needed to get all 8 valence electrons. An example of this is magnesium, which is a metal, and chlorine, which is a nonmetal. First you write the symbol and the number of valence electrons, and we're going to move 1 valence electron to our first chlorine atom, and this will give it 8 valence electrons. You cannot move any more valence electrons to this. So we now must draw a second chlorine atom and move our second valence electron from magnesium to it. This will give magnesium +2 charge, chlorine a -1 charge, and another chlorine with a -1 charge. Our final part is the formula, MgCl2. This is because we used 1 atom of magnesium and 2 atoms of chlorine to get all the metals with 0 valence electrons and all the nonmetals with 8 valence electrons.